So today we welcome two very special guests to speak about our new genetic testing program called TestFSHD and also about genetic counseling. Dr. Jamshid Arjamand is our Chief Science Officer here at the FSHD Society, and Tara Newcomb is a certified genetic counselor at Genome Medical. Jean, would you like to properly introduce our guest speakers?
Yes, I think many of you already know Jamshid Arjamand, but I just want to emphasize how fortunate we are as a society to have him with his experience, both as working as a lab neuroscientist and then working for the Cure Huntington's Disease Foundation for many years, where he was involved with a large virtual drug development enterprise for Huntington's disease. So he has that deep kind of nonprofit, kind of venture nonprofit, I don't know what the word is for that, but experience, as well as at Genea Biocells, which was involved with an FSHD program a number of years ago. So he's got it all. And now he's working with us, and it's so amazing. It's like getting an extra pair of booster rockets to loft us into the stratosphere. So that is what I have to say about Jamshid. And Tara Newcomb, our guest today, is a board-certified genetic counselor specializing in neurology genetics, including pediatric neurology. She completed her Master's of Science in Genetic Counseling at the University of Utah in 2010. And Utah is a powerhouse in this area. So these are very great pedigree to have. Prior to joining Genome Medical, she worked at the University of Utah in pediatric and adult neurology clinics, as well as in neuromuscular genetics research. So Tara is passionate about helping individuals and families navigate the genetic testing process. And during what little spare time she has, she says she enjoys exploring the outdoors with her family. So she's joining us today from Nebraska. So with that, I'd like to turn things over to Jamshid.
Thank you so much, and thank you so much for showing those pictures of us where both, it looks like Tara and I both had shorter hair at the time. I guess there are slightly older pictures. All right, let me see if I can share my screen without ruining everything. Is this working? Did I crash the system?
No, it works great.
All right. Wonderful. Well, thank you very much. Really appreciate being here. And so now if I can advance past the slide. Okay, thank you very much. So today we're going to talk about genetic testing, but I wanted to take a step back and maybe give a bird's eye view on the drug development process and basically how this whole endeavor for genetic testing kind of came about. So want to just go over what are the critical ingredients for developing a treatment in FSHD. Well, one of them is we need to know something about a disease like FSHD. So the society's been funding basic research for close to 30 years. And this is something that we continue to do. And it's always critical to understand more about disease progression, the molecular mechanisms that are involved in disease pathology. And so this is something that we continue to do. And this basic research is actually what allows drug companies then to develop strategies and develop drugs that they think is going to help slow down or treat the disease. And this is really proprietary to the drug companies. And from our perspective, we would like as many shots on goal as possible. And so from our perspective, the more companies find that there is enough known about the basic biology of FSHD, and they start developing a program to develop drugs and a treatment, that's really a win for everybody. So we're very happy now that there is probably around 20 different companies. Some of them are small, some of them are larger, that are working on developing treatments for FSHD. So besides developing a drug, you actually need to then at some point show that a drug is effective. So for that, you really need instruments and tests. So you need biomarkers, you need outcome measures that you can run in the clinic, and those are really critical to show if a drug is working or not. To test the drug, you also need a clinical network. You need educated clinicians who are capable of running clinical trials, and you need that infrastructure to test drugs and test potential therapies in a really robust and in a really robust manner. And of course, none of this would be possible without having patients volunteering for the trials. And this is absolutely critical. And this is one of the reasons why we reach out to you when we send you so many emails about what's happening in the field. So everybody is aware of the latest developments and how they can participate and in various studies. So this area is actually where the society is really can have a really big impact in trying to accelerate drug development, because everybody needs instruments. The network of clinicians is absolutely, to run clinical trials is absolutely essential. And everybody, once it's established, all the companies can use that same network. And of course, volunteers, you guys are absolutely critical to this. So the more people are aware of what's needed to enter clinical trials and are eligible for clinical trials, then we'll have more and more trials that are successfully going to recruit and take place. So to address this area where that's common to all of the drug development, we've developed this program called the Therapeutic Accelerator. And the point here is really to identify bottlenecks that are common for all drug development. So everybody needs biomarkers to show that a drug is effective. Everybody needs outcome measures. All of the companies are going to need to run their trial through a network. So that becomes really important. And of course, everybody's going to be tapping in and asking for people to volunteer in their trials. So what we're trying to do with the Therapeutic Accelerator is identify these bottlenecks and then work with companies, with academic researchers, with whoever is necessary, contract organization, to find a solution, and then to work collaboratively to develop a result or a solution or a tool that everybody can then use to then advance their drug through the clinical trial process. So I've mentioned clinical trial readiness or clinical trials. So let's just take a brief overview of what that is. So clinical trials are really controlled scientific experiments. And I put controlled in a parentheses here because in a lab, when you're running cells in a test tube, all of the cells are going to be the same. So they're just clones of each other. Even animal experiments are clones of all the different animals are clones of each other. And the only variable there is usually the treatment, the drug or the condition and time. Those are, you try to minimize the sources of variability. So typically the treatment is the only variable there. And then obviously there's some sort of a measure or a metric, something that's being tested, an outcome, and that's part of the test. And then of course the sample size, whether they be cells, mice, or people, this is kind of becomes, that's how you power a study. You're trying to see a certain effect and you need so many people in a study to see a statistically significant effect. And that's kind of how you run these clinical trials or scientific experiments. Now, to keep the variability at a minimum, what clinical trials typically have, they have inclusion and exclusion criteria. And this has come up several times where people really want to volunteer for a study and then they find out that they don't qualify, that they are they don't meet the they don't have the appropriate criteria, and that's typically because of these are the typical things that are part of the inclusion exclusion criteria. So usually trials might be, they may have an age limitation. And in FSHD, there haven't been that many clinical trials in the past, but typically they're restricted to adults. And there's a reason for this. Adults, usually teenagers or juveniles they're growing. And so if you're trying to treat them with a drug that will slow down muscle degeneration, it's going to be really difficult to separate the effects of the drug versus the natural growth. And as kids grow and they go through growth spurts, that can actually add variability to it. And then adults over the age of 65, typically we all start losing muscle mass at some point. And so there is the natural loss of muscle that happens in older adults. And so that can also create some variability. And so typically studies are designed to include adults. And if the drug is approved and is successful, then it will be hopefully available to the entire population, irrespective of age. Disease manifestation and the degree of the advancement of the disease is also something for consideration. And this is really going to be dependent on the type of drug that's being developed. So some drugs may be looking at increasing muscle mass. So they may want patients that have slightly more advanced disease progression, whereas maybe some drugs that are being developed that are, let's say, some sort of a viral vector or something like that, they might want to target a younger population that's less affected. So that's really going to be defined by the pharmaceutical company and what group they think their drug is going to be able to show the best effect. And again, this is an experiment they're designing, so they're trying to identify the group, a subpopulation of a patient population where you're going to see the predictable effect. And then genetic confirmation is another criteria that's we've seen has been implemented in various trials. And this is just because FSHD is difficult to identify, and quite a few people are misdiagnosed with FSHD. And if you have people with a limb-girdle disease entering a clinical trial for FSHD, they may not respond to the drug, and that adds variability to the results. And then your trial risks failing, not because the drug was bad, but because there were people that were misdiagnosed that were participating in the study. So we've noticed that this genetic confirmation is actually a major bottleneck for people who want to participate and volunteer in clinical trials. And with several trials coming up in the next year or so, we want to make sure that that is no longer a bottleneck. And so the whole goal of this initiative is to provide the community with a clinically approved genetic test that would meet the anticipated inclusion and exclusion criteria for participating in a trial. So hopefully this gives you the stage of why we're doing this and how the target audience we're trying to reach with this test. So let me go a little bit into the genetics. I'm sure you've seen this diagram many times before, but as you know, there's two types of FSHD. Both types are caused by the misexpression of DUX4, but the genetics that underlie the two types of FSHD are quite different. So I don't know if you can see my pointer, hopefully you can. This is a healthy chromosome, and you can see these purple ovals. They are repeat units, so these are long stretches of DNA. And typically on chromosome 4, you have a whole bunch of these, anywhere from 20 to 100 of these repeats. And these repeats tend to get modified, so the DNA actually gets tagged like a Velcro, and it gets closed up. And the last unit here has a full, the DUX4 gene, the toxic gene in FSHD, is in the very last unit. And there is a signal at the very end that's outside of these repeat units that basically stabilizes the DUX4. And in the case of FSHD type 1, which is the majority of the diseases, about 95% of FSHD is caused by FSHD type 1, is you get a contraction, you basically get an elimination of these repeats, and so consequently, you get less of this Velcroing effect. And if this allele, if the stabilizing part of DUX4 is on the chromosome, there's a higher likelihood of DUX4 being expressed because the DNA is no longer compacted, and it can misread and make DUX4 when it's not supposed to. In FSHD type 2, this is only 5% of the cases, and most of the mutations are in an enzyme that actually tags the DNA and is kind of basically closes it up so it doesn't get expressed. So obviously, if you cannot tag the DNA and it doesn't get condensed, there's a higher likelihood of DUX4 being expressed. So this is just a very quick overview of what the genetics of FSHD is like. And the reason I kind of wanted to talk about this is because the genetics are quite complicated. And so most people go through a diagnosis, and the first diagnosis is a clinical one. And I here I've highlighted, or I put experienced clinician in quotation. And so if you have the opportunity of seeing an experienced neuromuscular specialist, most of them will be able to distinguish between FSHD, Duchenne's, and limb-girdle. But other neurologists, maybe the ones that specialize in Alzheimer's and Parkinson's, they may not know much about neuromuscular disorder. And so that's how a lot of people get misdiagnosed. They just don't have access to a specialist that can recognize FSHD. So this is one of the reasons last year we created a course, continuing medical education course for neurologists, specifically to train general neurologists on how to diagnose and recognize FSHD as a distinct disorder. And then for genetic tests, there are research grade tests. And so, for instance, the DNA methylation test that's being offered through Dr. Jones's lab at the University of Reno is a perfect example of a research test. It's very cost effective, and it's just looking at the Velcro, the DNA methylation on that part of the DNA. So this is a great research test, but it has not been clinically approved. For a clinically approved test right now, the criteria are that it needs to either measure the DNA repeats themselves and the haplotype. This is kind of that 4QA thing at the end that I said stabilizes the DUX4, or you need to look at the DNA methylation, and then you need to look at the genes that are involved in adding those methylation or the Velcro tags like SMCHD1, or there's two other genes in there, DNA methyltransferase, and there's another one that was recently identified. And you need to sequence through those to see if there's a mutation that could cause hypomethylation of the chromosome and cause FSHD2. So this is basically what clinically approved testing is, and that's what usually pharma companies require as an eligibility criteria to enter a trial. So why would anybody want to get genetically tested? So obviously, especially in spontaneous cases, people will start realizing that maybe they can't run as fast, or they can't lift their arms, and they want to know what's going on. And so they go through their general practitioner, and for some people it might take 5 to 10 years to get a proper clinical diagnosis of what disease they may have. And so recently, in 2018, there was a code, ICD-10 code that we helped generate specifically for FSHD. So in the past, I think there was a general code for muscular dystrophy, and it didn't distinguish between the different types of muscular dystrophy. So this code, ICD-10 code, is specific to FSHD. And now clinicians who diagnose or make a clinical diagnosis for FSHD will use that code. And that's actually going to be important later on for reimbursement and for all kinds of insurance benefits. So the other reason why people want to have a genetic test is for family planning. If FSHD is in the family and a couple is getting married, or they're planning to have children, they may want to know what are the chances that they carry the mutation, even if they are not manifesting any symptoms, and what are the likelihood of passing on the mutation to their children. And obviously, the last one would be for clinical trial readiness for people who want to participate. This becomes kind of an inclusion criteria. And we anticipate that once there is a therapy on the market, insurance companies might require genetic testing to provide reimbursement for the drug. So this is all good, why somebody might want to go through genetic testing, but of course, there's pros and cons to everything. And once you have a clinically approved genetic test, it will go on your medical record, and this can have some adverse consequences. So the pros we just discussed, but the cons is like, even though about over 10 years ago, there was a legislation passed called the GINA Act, the Genetic Information Non-Discrimination Act, that protects people with genetic conditions from losing their jobs or losing their health insurance. There are some exceptions to this law. It doesn't cover life insurance, disability insurance, or long-term care insurance. So people who are diagnosed with muscular dystrophy are typically not able to secure these type of insurances. So this is why it's really important for people to discuss with a qualified genetic counselor on whether this is the right thing for them to do or not, whether they should get genetically tested and have that go on their records or not. So, and every person is going to be different, and that's why it's important that everybody gets a chance to speak with a genetic counselor. So let's go over the genetic testing flow. I just wanted to highlight something here, that genetic testing has technically been very challenging. And just a couple of years ago, they were using really old methods. That was really the only way of doing it. And this figure is taken from the process at University of Iowa that's been providing genetic testing for quite a long time. They were using a technique called Southern blots, and it's really time consuming. And so the first thing, since 95% of the cases are FSHD type 1, this is the process. They first look to see if that stabilizing part of the gene is available. And if it is, they actually would run this complicated experiment to see if there's contraction, if there's a loss of those repeat units. And if that was negative, and they would then go to another process. They looked at DNA methylation to see if those Velcro elements were present or not, and if there's a certain reduction, if those measures were below a certain threshold, then they would start sequencing and trying to get all of the genes that are involved in FSHD type 2. So SMCHD1 is the predominant mutation that causes FSHD type 2. So as you can see, these two tests are quite independent, and only if it fails to show a positive symptom in FSHD type 1 would FSHD type 2 be done. And we already know that there are families who have actually mutations in SMCHD1, and they have FSHD type 1 as well. So we know that having some mutations here can actually accelerate and make the disease more severe. However, we typically, since 95% of cases are diagnosed as FSHD type 1, FSHD type 2, or the sequence of SMCHD1, is never known. It's never sequenced, it's never tested, and that's kind of a major gap. So this is why I put we miss the dual hits. And there's newer methods that are being developed, and so that are faster and cheaper. And this is something that this program is capitalizing on, is using a better method than the old Southern blots. So let's go over the elements for a clinically approved genetic test. So as some of you who may have gone through this, you need to go see a clinician. A clinician should then be familiar with FSHD to order a test, and they need to then know where to go to order the test. So if you're lucky enough to be at a clinical trial research network site or somewhere where they're experts in FSHD, they know how to do this. But most neurologists don't know where to begin to order the test, because this is not a routine test. It's only being offered at very specialized and only a few places around the country. So they wouldn't know how to order it. So the next thing is you should really have genetic counseling to really discuss the pros and the cons of how having a clinically approved test will impact your medical record, your health insurance, and all of that. Quite often these tests are expensive. So, and insurance companies don't really want to pay for these. There are always issues with getting reimbursement. There is always the option to self-pay, but as I mentioned, the older methods were quite expensive. And some people could afford that, but a lot of people, it's out of range for them, and it's a difficult thing to pay for, especially if there's the recommendation is coming from a non-expert clinician. So is it really FSHD or not? So this comes to the next step of, what if somebody has or they think they have FSHD, they go through the whole process and then they don't have FSHD. What happens then? They probably have another neuromuscular disease, but they don't know what it is. So for them, they're going to be, they don't have an answer, and it must be very frustrating. As I mentioned, diagnosis can take 5 to 10 years, and they're back at square one. So we just wanted to make sure that our program addressed this as well. And more importantly, for newly diagnosed patients, what happens to them next? So we wanted to make sure that people are not just left with the diagnosis of FSHD and not know what the disease is, and then they have to Google it on their own. So we wanted to make sure that there is a path forward for newly diagnosed patients to get in touch with the society and to meet other groups and maybe learn about the chapter programs and get peer support and all of that. So we were very lucky and very grateful for the generous support of all of these companies listed on the right that kind of thought that this was a good program and it was beneficial for the community. And so they have all contributed to this program. I just have to say that this is a pilot program, so it's only for about 150 patients. And but we're providing fully sponsored genetic tests, and it's been specifically designed to increase eligibility for clinical trial readiness. So there are some eligibility criteria. We are trying to anticipate what the common eligibility criteria for most upcoming trials will be. This is probably going to be, trials will be restricted to adults, so 18 to 65, and people who are symptomatic, either with a family history or with a clinical diagnosis. And the symptomatic, it can be any range of symptoms, but they need to be symptomatic, because if people are asymptomatic, there's no improvement to be tested. So the trial would not show any improvement on the drug. So that's why symptomatic is a criteria here. So the program that we have put together is quite complicated. There's a lot of moving parts to it, but we're very happy that all of the different groups are participating in it. So the society, we're providing the marketing and the educational, so the webinars like this one to let people know that this program is active. Genome Medical, we'll hear about from Tara very shortly about how Genome Medical, the services that they provide. So there's a centralized portal. This is really a direct to consumer offer. So you can log on to the website, make your appointment for a genetic counseling. If you meet the criteria, there are options for, they will provide the medical referral to get the testing, and the test will be ordered. There is a phlebotomy, there's a blood draw that takes place, and we've tried to use a service that's throughout the country, is available throughout the country at LabCorp. And then depending on some criteria, the blood samples will either be sent to PerkinElmer or University of Iowa. They are both using the more advanced methods for genetic testing. And really the thing that's interesting here is that they are providing not only genetic testing for FSHD type 1, but they're doing it at the same time, they're providing the sequence to SMCHD1 for FSHD type 2. So both of those are done at the same time for everybody. And the results are then sent back to Genome Medical, and the genetic counselor then will make an appointment and with you and explain the results and next steps forward. And this is kind of what the general flow is and what all the different groups are doing. So with that, I'm going to turn it over to Tara and have her describe in a little bit more detail what Genome Medical does and what talented genetic counselors like hers do when they speak with patients.
All right. So I'm Tara. I'm a genetic counselor. I work with Genome Medical and have been there for about 2 years. So just a little bit of overview about what genetic counselors do in general. So we're trained medical professionals, specifically in human genetics as well as counseling. We often meet with patients and discuss hereditary genetic conditions affecting either an individual or a family. We discuss testing options, as well as really help with medical decision making, support individuals through that process. Really walking through one person's pros and cons of, is genetic testing right for you? Which genetic test is right for you? And trying to help make sure people understand not only the testing that they're getting, but possible implications for themselves and family members. And that's just kind of genetic counselors at Genome Medical, as well as genetic counselors throughout the country, right? Through at specialty clinics. We do a lot of genetic testing, not only in neurology and neuromuscular disease, but other areas as well. And you can go to the next slide. So in a genetic counseling visit, kind of what to expect. At Genome Medical, we see people with many different types of genetic conditions, including FSHD. So all of our counselors have been trained in this disorder, as well as other forms of muscular dystrophy, Duchenne muscular dystrophy, limb-girdle muscular dystrophy. So these conditions are not new to us. It's something that we have seen many times. Several of the counselors at Genome Medical, myself included, have come from in-person clinics. So we were experienced with this disorder. We are also experienced with other rare diseases and have a network of individuals we can go to for people who may have more complex cases or histories to be able to bring hopefully the most useful information as far as testing strategy for each individual patient. Part of our training is to help translate some of this complex medical information, hopefully into things that more people can understand, and so that you feel like you can own your genetic information and use that for your personal and family benefit. Again, that assistance with decision making, I feel like that's a lot of our job, which isn't necessarily disease specific, but in general, walking people through this kind of complex process of genetic testing, thinking through, okay, what happens if I test and come back positive? What happens if I test and come back negative? What happens if I elect not to do testing? So just because you schedule an appointment with a genetic counselor does not mean you have to go through with the genetic testing portion. We see patients where after a discussion, they decide that it's not the right move for them at that time. And we can either revisit testing in the future or, I mean, it's not, like I said, not something you have to do. We do have counselors throughout the United States. At this time, we don't have any availability for genetic counseling in Canada, but we have counselors throughout the US with licensing in various states, various time zones. So through Genome Medical, we are able to meet the needs of a wide variety of individuals, and hopefully with our network of genetic counselors, able to provide services in a timely manner for everyone. You can go to the next slide. So kind of what happens at an appointment and what to expect kind of before, during, and after. So before an appointment, you're scheduled with a specific genetic counselor. All of these genetic counselors, we have kind of categories. So you'd be scheduled with a neurology genetic counselor. You may be asked to take a survey, which would ask questions about your personal and medical family history, just to be able to give the counselor that you're working with some information ahead of time to know what to expect, if there's anything unusual we should prepare for, and to just let us get a head start on that information. During the appointment, these appointments are scheduled for 30-minute slots, but usually we leave some buffer, some wiggle room in case it does go long. Genetic counseling appointments, both in person and through telehealth services like Genome Medical, often have a lot of the same information, same kind of concepts that we're going through. So an in-person visit may maybe longer if you do elect to, see a genetic counselor associated with your neurology office. But really, we start by discussing, okay, what are the goals for the session? What information do you hope to gain? What kind of questions are we going to ask you so that everyone's prepared and on the same page? We do review your medical and family history, things that we're looking for to assess disease progression so that we can inform which testing options might be best for you, as well as provide information back for appropriate clinical trial options. So helping to collect that information in a standard way so that we know, okay, these patients, here's who's tested positive, this is kind of where they're at in the disease process. And that just helps you then be matched up with the best clinical trial moving forward. We do review any testing options. Like I said before, you don't have to move forward with testing. Depending on medical and family history, there may be an alternate test that's better for you or for a family member. You may come to talk with us, and after discussion, we may say, I know you're here now, but really your brother or your sister or your dad might be the better person to start with testing. So really just making sure that we are being thoughtful about the process so that we get the best outcome. We are also able to discuss, additional testing if FSHD testing is negative. As mentioned before, what do you do then? So we have the ability to kind of think critically about all of the information to say, okay, this person should have test A versus test B, or really you should go see a neurologist and make some recommendations there before moving forward with further testing. Genome Medical is a telehealth company. We can't provide those exam services, but we are able to help identify someone close to you that may be able to assist with that. And then the other part of the visit is really discussing, some of the possible genetic discrimination through GINA. What can we do to make sure that you understand the possible implications of genetic testing that could be a more negative implication? Those things that GINA does not cover: life insurance, long-term care, and long-term disability. What of those can be put in place before testing? Do we need to delay testing so that you can have some of your affairs in order? Things like that, just to help people, again, talk through and work through that process, especially if it's something that hasn't been thought about before. And then discussing how you'd like to receive your results. So typically we do schedule results visits to discuss any positive results, as well as for affected individuals, results visits to discuss negative results. Just because you have one negative test doesn't mean that this is the end of the road and we have to be all done with genetic testing. There are usually additional options. After your appointment, we will give you written copies of all of the information. So a copy of your test results, a summary that at least attempts to walk through what we found in a way that's hopefully a little bit more understandable than just the lab report. So it has some interpretation, recommendations for next steps. And then we also discuss, okay, where do you go from here? So is this now a referral to an MDA clinic near you? Is there another neurologist nearby that has experience with FSHD? Are there clinical trials available that you might be interested in, and can we connect you back to them? Option of consenting to have your information shared back to the FSHD Society so that they can help be a part of that connection from diagnosis with genetic confirmation to now accessing these other programs and information that is available. So we want to make sure that you get both the medical information as well as the other support from other affected individuals or family members, so that you feel empowered by the information and kind of ready to move forward.
Jamsheed, if you're talking, you are muted.
Okay, that explains why the blank stares. All right. Thank you very much, Tara, for this very comprehensive overview of what you and your colleagues do. It's really critical, I think, for since it's such an individual decision to decide whether to go through with the genetic testing. It's really important for people to have that opportunity to meet with a genetic counselor and explain their particular situation and be able to make that decision for themselves and for the that's going to be suitable for them. So thank you for explaining all of that. Also, I think that one of the things that I'm that you touched on is that this is telehealth medicine, which is fantastic. So the appointments, this on the right side of the slide here this is what the landing page looks like. And there's a link from the FSHD Society to it. I forgot to put the link up here. My apologies, but we can probably put it up at some point during the Q&A. But the eligibility is described. And then this is just the one click where you can schedule the first appointment with a genetic counselor. And it's a video or conversation, or it can be by phone as well. But there is no travel. As Tara mentioned, there are counselors in all different time zones, so you should be able to make an appointment. And so the way it works is that the portal opened on April 18th. When you first sign on, you create a profile and you sign 2 forms, a privacy practices and a consent form for the testing. And then you can make a genetic counseling appointment for, it usually takes 7 to 10 days, but of course, when there's a flood of people making appointments, they take up those slots up, and so it might be delayed. So don't be surprised if you try to log on and there's a 14, maybe 2 weeks, 3 weeks before you can get an appointment that suits your schedule. After the appointment, if you decide to go forward, the testing center will ship you a kit that will come to your home. And right now, as I mentioned, we just launched this. There's a lot of moving parts. So we had some patients that were going through the beta testing and pressure testing the system. And so we are making some modifications to the kit just so the blood draw can go smoothly. And so after you receive the kit, there will be instructions on how to find a LabCorp facility and to go there for your blood draw. And once the blood draw happens, that's it. You basically, it takes about 6 to 8 weeks for the test to be carried out and the results to be sent back to Genome Medical. At that point, you will get an email from Genome Medical that says your results are in and you can schedule an appointment to get the results. So what happens to ineligible candidates? So if people don't meet some of the eligibility criteria, maybe they're over 65. So there are other ways you can take advantage of this process. So there's always a self-pay option, but Genome Medical actually works with a lot of different insurance companies and they can help you navigate that insurance reimbursement process. There is also what happens to patients who may come back with a negative test results, but they are still symptomatic. They have signs of muscular dystrophy, it's just not FSHD. So Genome Medical works on a lot of different muscular dystrophies, and they provide genetic counseling, and they're aware of other types of testing. And that's what Tara was mentioning, that there are different types of tests for different diseases, and they will guide people to the appropriate testing if they want to continue down that way. So for instance, there is another types of free testing for other neuromuscular disorders that have a simpler genetic mutation that's easier to detect through conventional methods. And so they can direct people to that if necessary. So let me see, let me advance to the next slide. So, going over, the requirements for getting a clinically approved genetic test, a medical referral, this is actually being taken care of by Genome Medical. They will provide that and they will inform the right facility to send you the kit. They provide all of the genetic counseling, the pros and cons of testing, and again, the type of testing that is being offered to this program will cover FSHD type 1 and type 2 at the same time. For eligible participants, this is fully covered and free. So it's a fully sponsored and free testing service. And as a next step for newly diagnosed patient, there's an opportunity to be referred back to the FSHD Society for support, for educational material, and for information on upcoming clinical trials. And for those who may have tested negative, there are other avenues for other types of testing, so they are not left hanging without a diagnosis. There are other tests that they can use to identify what disease might be in their family. And the process that I showed, the chevrons and all the different parts, this is highly modular. So right now, Genome Medical is providing all of the genetic testing, and it's limited to the US, but the testing at the 2 sites are using certain newer techniques, but there are novel techniques being developed. And so if those come online and they're clinically approved, it's always possible to add them to the pipeline. It may be possible to add other phlebotomy groups, or maybe if at some point saliva testing can be done for a clinically approved test, the whole process can change. So it's highly modular. And so even though this is a pilot program and it's only for the first 150 participants, we anticipate that if it's successful, we'll be able to modulate it. And there's always a possibility that a pharma company will say, well, this is important, and they'll continue supporting it. So as I mentioned, we just launched this initiative a couple weeks ago. And before, as Beth mentioned, Patient Connect is around the corner. It's going to take place in Orlando, June 18th and 19th. I think there's a deadline for registration, both either in person or virtual. So make sure that you sign up for that. I think there's going to be more information on this type of testing at the Patient Connect. And with that, I'd like to thank everyone, and especially thank Tara for participating and for telling us the great job that an important job that Genome Medical does, and their contribution to this initiative.
Great, thank you to you both. Well, we do have questions coming in from our audience, and if you out there have other questions, please put them into the Q&A space. So we have a question here. I think many people will have. This person says, I have a confirmed positive FSHD test from 1999, and this was before FSHD type 2 was discovered. When it comes to eligibility to participate in trials, will the drug companies require confirmed tests that specifies whether you have type 1 or type 2 or possibly both? Essentially, I am asking if I should get a new test.
Yeah, that's a good question. And I'm not sure I know the answer. It depends on the company running the test. So I believe that in the past, people who had old tests were accepted, but everybody was retested with just for confirmation as part of the study. So if it's an old test, then that might be worthwhile to go back through it and get retested. That would be my recommendation, but I don't know exactly what the pharma company running the test, what their criteria is going to be.
Okay, and we have a question again from someone who had the previous Southern blot test. They're wondering how accurate or inaccurate it is, and I think this individual said she also has family members who are manifesting symptoms who tested negative, I think on this, maybe on the Southern blot test. So I think they are wondering what to do about that.
Yeah, that's a good question. So the Southern blot, I think if done properly, is quite accurate. And it, even with the newer techniques, I've heard that sometimes they go back to it just to confirm. So it's technically very demanding. And there's a certain amount of skill set that needs to go into conducting it properly. So if done properly, I think the test is quite accurate. But the newer methods actually are kind of eliminate that skill set. It's basically done by a machine. It is less technically challenging. So I think that would be a better way of doing it. Now, there are other genes and very complex rearrangements that can take place. So just counting the repeats may, on a southern blot, may not detect those rare cases when there is a genetic rearrangement. And this is when a part of the DNA kind of gets duplicated and gets put somewhere else. The newer methods should be able to pick that up. So did I answer that question?
Somewhat, I guess. It is a complicated area. This is maybe a more straightforward question. People are wondering how much the genetic testing costs today if you had to pay out of pocket.
So Perkin-Elmer put that on their website, and I don't know if it's still there or not, but for a while it was being advertised that the new testing for FSHD type 1 was $699. Do you remember that, June? Was it 700 bucks?
It was just under 700. I believe
Yeah.
that's still the case. Right. So, which is a lot less than before. With Southern blot, it could run $2,000 to $3,000 on up.
Yeah.
And if you have a family trying to test multiple members, paying out of pocket, that is really a burden.
Quickly.
Yeah. So there was a question here. Someone else who had a blood test done at the University of Iowa found a 4q35 deletion consistent with FSHD. Didn't state whether it was type 1 or type 2. So for that person, that is by definition, if it has that deletion, it's type 1. Should she redo this test to determine which type she has? So I think the answer there is no, but what is unknown is whether this individual might also have type 2, but I don't know that one would need to go to,
Probably
what do
not.
you think, lengths to try to get tested for type 2? Okay.
I agree. Yeah.
All right. And let's see. Would an adult offspring of a diagnosed patient be automatically eligible, or must they be symptomatic?
So for the inclusion criteria that we define, we're trying to mimic what we think upcoming clinical trials are going to have as their inclusion-exclusion criteria. The offspring would need to be of a certain age, they need to be an adult, and they also would need to be symptomatic. Because to enter a clinical trial, if people are asymptomatic, there is nothing to measure on improvement. And that's why being symptomatic is important. And this is one of the reasons, as part of the intake with the genetic counselor at Genome Medical, there is a brief series of questions about the level, the degree of the disease, how advanced is the disease. And that's just going to help with recommendations for us being able to recommend people to different trials based on the actual inclusion-exclusion criteria of upcoming clinical trials.
Thanks. So here's a question. What would be considered the old test? From what year was I guess, until when was the Southern blot test used, and when did it stop and become, now the current?
Yeah, I think the Southern blot is still being used. It's not inaccurate. It's just technically more challenging. So I'm not sure what old is. I think, unfortunately, I don't know that answer.
Yeah, I believe the University of Iowa switched over to the whole genome optical mapping in maybe in 2020.
I think so. Yeah.
Yeah, but and part of it is the Southern blot requires the use of radioactive chemicals, and a lot of labs are trying to eliminate that because of the whole safety, issues around that. So, but I believe, I may be wrong, I think they may still have the ability to do that, but just sort of as a backup if there's a really complicated, ambiguous case and so on. But anyway, so I'd say roughly around 2020 is when Perkin-Elmer started offering the new test. So it's somewhere, that cutoff is somewhere around that
Yeah.
time, I'd say.
And there are new methods being developed. There's an alternative method that was developed by a French company, by Genomic Vision, and I think that's being used in Europe and possibly in Hong Kong as well. There are now other methods that are being developed that are long read sequencing, and those are at the research phase right now. So as the tests become more predictable, more reliable, and robust, they may go through that whole process of getting clinically approved, but they would measure all the things that are currently required for a clinical genetic diagnosis. So they measure the repeat size, they measure the sequence of the haplotype, and this one actually can also measure DNA methylation, and you would be able to then sequence through all of the genes associated with SMCHD1. So we're hoping as those new methods are developed, and if they're robust enough that they can be swapped in, I'm sure most of the testing facilities will adopt those newer methods because they would be faster and even more cost effective and reliable.
So here's a question from someone who says they had confirmation of FSHD through muscle biopsy in the 1980s. So there was no genetic test at that time. So would that eliminate me as a candidate for genetic testing?
No, this is, I don't know how they would have done this through a muscle biopsy. It's usually through a clinical exam, but that's a perfect situation for going through this process.
Yeah. My understanding is they might have used a muscle biopsy to rule out other myopathies, but it's not really a gold standard test confirmation of FSHD. It's kind of like, we can't think of anything else that might be. So it might be that individual. It might be important to get the testing. Well, you have to ask yourself, what would that accomplish? Because obviously one is that you would be eligible. If you are otherwise eligible for a clinical trial, yes, you should get genetic testing. If you have family members who might be impacted, would certainly recommend getting genetic counseling to talk about, the benefits of getting a genetic confirmation. Here is someone who's saying, if I pay for my own test, can I get into a study as I'm over 65 years?
Yeah, that's a good question. Again, we are guessing as what the eligibility criteria might be. And we don't know until the pharmaceutical companies publish their clinical trial protocol, what those inclusion-exclusion criteria are. So we are basically designed this program and the eligibility based on historical trials, and we try to be as inclusive as possible. But obviously, as trials they're going to have different eligibility criteria, so it's very difficult to predict at this point.
Right. So here is a question. The first part of that is, are there more drugs coming along that we expect to go into clinical trials? And the second is, if we have this genetic test, is it guaranteed that you'd be eligible for those trials, that you can enter those trials?
Whoops,
I'm sorry.
Yeah, that was, is there a way of getting it back? So I already forgot the first part of it.
The first part is, are there other drugs coming along?
Oh, I hope so. I know that there's at least 3 other clinical trials that are slated to begin as a phase 1 end of this year or early next year, right?
Correct. Yeah.
Okay, so that's very exciting. So yes, there are more trials on the horizon. There is no guarantee, unfortunately, because again, the eligibility criteria that we took were the broadest ones that we think are going to be part of the inclusion-exclusion criteria of a trial. But we really don't know what the trial is going to be. So for instance, for some company may choose that to show the effect of their drug, they will be better. They have a higher likelihood of showing a positive effect if they restrict the testing for patients between the ages of 30 and 40. They may decide for some reason to do that, to only restrict their clinical trial for a small age range. So then there is no guarantee that somebody who's like 45 would qualify on that for that test. Unfortunately, we don't know.
Thanks. Thank you for that. Well, I think we are out of questions and out of time for now. So I'll bring back, first off, thank you to our speakers, and back to Beth.